All right. So these are the four charges we are referring to, and they're on the square of the side length A. You have to find the ratio of Q by Q such that the force on Q is 0. So you're saying the force on the fourth charge is 0. So FQ, the force on Q is due to how many charges? Three charges, right? Let me call it
Right.
charge number 1, charge number 2, and charge number 3. And this is our Q charge. And you have to find
Right.
the ratio of Q upon Q if it is known that the force on this is 0. If I were to calculate, first of all, let me tell you that this is your diagonal. This is 45 degrees. Since these two charges are like charges, it's a repulsion force, okay? So
Okay.
I am doing this question with the help of vectors. All right, let's
Right.
look at the, so which means this charge will run away due to plus q, but it is not running away. So let's say the force due to q is in this direction and the force due to the other q is in this direction. We really don't know whether the forces are repulsive or not. It's my guess that q, both the q's repel
Repel.
q. That's my assumption. I don't know.
Okay.
Okay,
Okay.
I have really no clue. If this is the case, and at this moment the charge under consideration is experiencing a repelling force like this, a
Right.
repelling force like this, and a repelling force like this,
Right.
right? So it is experiencing. If you were given this situation, so if I were to say this is fa, the force due to a, this is fb, the force due to b, sorry, this is fa, right? It is vertical. So this is fa
Right.
and this is fb, for example, the force which is repelling force, and then the diagonal force, let's call it fc. If this is the situation, what will happen to q? Q actually will is getting simultaneously being acted upon by fa and fb. The resultant of these two will be, if I complete the parallelogram, this is the resultant of fa and fv.
Okay.
Okay, which means fa
Okay.
and fv together also will take it towards this direction, which is away, and there is another repulsion coming from q towards this direction. So overall this charge will run away because of fa and fb's resultant being along this line,
Okay.
and because
Right.
this is a square, and also
Mm.
q is another force which is making it move along the diagonal. So it cannot be stationary with our assumptions. It will run away to along the diagonal.
Okay.
Did you get it? This
Yeah.
force, the magnitude of FA, this force, or whatever you want to call it, FB, is same as FA, but both are perpendicular to each other because the distance is same, the charges product is same. FA can be
Mm.
written as, if I would, sorry, FB can be written as KQ by A square
R square.
away
Okay.
from Q, which is this, on towards the right. The force which is coming from here, which is FA force, which is upward by the way, is equal to KQQ by A square magnitude wise, but upwards, which is what I drew, this one.
Yeah.
Both the two forces are equal because they are, at the same distance. The magnitude
The
wise they are
magnitude
different,
is
but
equal.
the
Yeah.
only thing is the charge is experiencing them at perpendicular because of
Yeah.
their locations, right? The
Okay.
resultant of these two forces is this law of parallelogram. Okay, and there is another force opposite to q, which is plus q, which is also acting along the same diagonal, which means practically q is being pushed away by a combination of this charge and this charge acting diagonally, and anyway the third charge is going to act diagonally, fc. So our assumption that q repels plus q is wrong. The
Okay.
plus q should be then an oppositely charged unlike charge. If I
Oh,
reverse
okay.
now the direction, and I make a direction like this. Okay, let me redraw the diagram so that vectorially you first understand what is happening. Let me redraw this and show you what's happening. Now we know the total charge on this, total force on this charge is 0. There are two charges. In the previous case, we assumed that this charge repels this charge and this charge also repels this, and therefore this charge was experiencing forces like, and due to the third at the diagonal, this was a direction, and the resultant was along the diagonal running away. But we know the force on this has to be 0. There cannot be any resultant. This time I'm
Right.
assuming Q attracts Q towards it.
Okay.
They are attractive in nature. Now let me draw the vector. On the left, on the left hand side, the force Q, charge Q, is experiencing a leftward force like this. Attractive force
Okay.
from Q. Again, it is also getting attracted by the downward charge, which is of reverse sign. That's the only way you can get attracted. Earlier you were getting repelled, so you were getting repelled, you were
Mm.
running away. This time you want to go towards them. And then if you see the resultant of two forces which are along the sides of a square like this, the resultant is along the diagonal,
Okay.
which means this is uh, Q divided by A square. This is first Coulombic force, which this charge is calling it, saying come to my side. And the
Right.
charge here
Okay.
also is calling it with the
Downwards.
same force and saying please come down. Now this charge, however, is identical and it says don't come, I will repel you. So which means the resultant of this and this, which is this, is cancelling this.
Okay.
These two together want to bring the charge here. This one and this one, when applied, want to bring the charge here. But
Cancel.
this charge wants to make it run away. And therefore, if
Right.
this force and this force becomes equal, the resultant on this charge is going to be 0. Make sense? It will not move. Now we just need to
Yeah.
use this concept to find the ratio of the charges. I will
Ratio.
start writing
Mm.
the resultant now. The force number 1, which is the force number 1 towards left, which is an attractive force being experienced, F left is equal to KQQ by side of a square A. And then there is a downward force, F downward is equal to KQQ by A square. Now these two are at right angles. Let me draw them correctly. This was leftward, the other one is downward. Therefore, the way to solve this is the first one, tail, the head, and then the second one, which is this, it's tail
Tail and head.
and the head. So tail,
Okay.
head, tail, head. I have drawn them correctly now, and now I know the resultant will be this. And if I have to calculate this resultant, it will be using Pythagoras. So the resultant will come out to
Okay.
be, this is base or perpendicular, you can take
Mm.
Pythagoras, is
Or
equal to
addition.
F left square plus
Left
F
side.
downward square
Okay.
is equal to under root of KQQ by A square plus
Plus.
KQQ by A square whole square
Okay.
is equal to
Mm.
root 2 KQ by
Okay.
A square. This is the resultant force you got, which is this. Both of them, if you want to find the direction of this force, which is this angle, you know this, let's say theta. So tan theta will be equal to perpendicular divided by base. I am going to write tan theta is equal to KQQ by KQQ by A square. Right? I have written the magnitude of the leftward force and downward force as a perpendicular and a base. This is perpendicular. Perpendicular
Mm.
divided by base. I get theta is equal to 45 degree. So even we have proven that the force due to this left and down is 45 degree, which means it is along the diagonal. It is
Okay.
along the diagonal. And if you notice this particular third charge, which is Q, it is also along the diagonal. Right? So these two cancel.
Right.
This is
Yeah.
45
Okay.
degrees repulsion coming from here, and this is the net attractive force we have calculated also along 45 degrees. Therefore, these two are equal and opposite forces. Now we know the resultant of the two downward and left
Yeah.
charges. Let's calculate the force on the charge due to this. It will be force due to Q on Q diagonally is equal to K at Q divided by upon
And
the diagonal square, right? The distance between them is diagonal if you notice.
yeah.
What is the length of a diagonal? Root 2 A,
Square root a by 2.
right?
Yeah.
Root 2 A square plus A square ka under root. So I'm writing this as root 2 A whole square.
Yeah.
This is a repulsion force. So the charge at Q, this charge is facing this repulsion which we just calculated. So this is repulsive if you notice. Away. So if I redraw the diagram, Q is applying a force Q which is repulsive, right?
Yeah.
These two charges together come down and try to bring this charge in the same direction as the diagonal. So
Right.
these two forces are equal and opposite. Therefore, I'm putting this force, which is
Cancel.
kq square by root 2 a whole square, is equal to this force root 2
Okay.
kq upon a square. K gets cancelled, so I'm left with q square upon 2a square is equal to k q. So these are k q. I'm sorry. So k q. So k has got cancelled. I'm going to write q divided by a square. A square also gets cancelled. The q also gets cancelled. I'm left with q upon q to be 2. So the
Okay.
q charge is double that of the other two charges. It's right. This is the only
Yeah.
way you could have ensured. So it was guesswork, but mind you, because I
Yeah.
have more experience than you, I would have done this faster. The moment I see a question
Yeah.
like this, where I see the
Okay.
resultant is 0, I actually knew what is going to happen in my mind because my vector is very strong. I know this is Q
Okay.
and Q, so this has to be a repulsion at 45 degrees. Then I said,
Okay.
I am assuming this to be of the same sign as
Positive.
this. So repulsion, and this is also repulsion. I would not have
Okay.
done that because my knowledge of vector is very good. I know if you have two
Right.
vectors like this and I draw a line parallel to the other one to complete my tail head, I will get the answer like this, which is nonsense because it gets added to this. Both
Right.
get, then why will this be stationary? We want the net force to be 0. Since my knowledge of vector was very good anyway, I would have straight away taken that the charges are unlike sign and would have taken like this, that the resultant of these two is this and the third charge is pushing it like this. These two cancel.
Okay.
Make sense?
Yeah, I got it.
Tell me if you
Mm.
find anything, something which is like extraordinary or some
Yeah,
type.
this was a little new
Yeah, I
because I
mean,
was
my see, I
confused at
okay. Just one
this time.
simple correction. Root 2. Okay, so I forgot to write a root 2 here. Okay, a root 2. So which this root 2, right? Root 2. The which I got from
Yeah.
Pythagoras.
Yeah.
Okay, so this root 2 I will add, and therefore I will write q
Okay. Okay.
q1 q upon q is equal to 2 root 2 actually.
Okay.
Q is equal to 2 root 2, but The signs are different. I know that these two charges are of different sign. Therefore, I will write a minus also to tell you that the sign of Q and this Q are reverse. Just getting the answer Q is equal to 2 root 2 Q was not enough because it doesn't give you enough information about attraction and repulsion. I know the other two charges wanted to attract it. So as compared to this charge, Q is negative, and therefore I've chosen this as a choice.
Got it.
If you understand vector,
Then it's
50%
easy.
of physics is done verbally. I just did this to
Right.
explain you stuff, nothing more than that. There was nothing in this. I could have done this in 1 second, but I wanted to give you a perspective how to think like a vector, resultant. Next one.
Okay, the next question, only the 14th one. They asked us about, they asked the question of gravitational and electrostatic force on the proton.
Question number?
14.
Okay. So they want you to compare, right?
No, they just asked, find
Okay.
the gravitational
So you have a
electrostatic
charged
force.
cloud system producing an electric field, yes, and then says it is near the Earth's surface. A particle of charge -2 into 10 raised to power -9 is acted on by a downward electrostatic force of 3 into 10 raised to. When placed in this field, the gravitational and electrostatic force respectively exerted on the proton placed in the field are okay. So okay, see, a lot of electrostatic is studied like this. So let me just draw a diagram first to make you understand what's happening. Okay, so this is your Earth's surface.
Okay.
Okay, this is your Earth's surface. There is a some type of minus charge collection near the it says a charged cloud system produces an electric field near. So there is some lot of collection of charge here. Okay, let's say it's a plus charge. Okay, we will just find out why and how. So near the Earth's surface there is air, and in air you breathe. Sometimes you do have accumulation of charges in the air. Okay, which is
Right.
electrostatic. It doesn't flow. The charges are just there. And now what is happening is there is a charge, negative charge, which is being acted on by a downward electrostatic force. So the negative charge which is experiencing the force is this.
Okay.
Okay, and the question says this charge is experiencing a downward force of 3 into 10 raised to power -6. Tell me, if the cloud of charges is positive, will it try to bring it up or down? If the cloud, this is my cloud, right? This is my
Right.
cloud. This is positive.
Okay.
Will it push it downwards, this isolated charge, point charge, or upward?
Towards itself, down.
Yes, but in the question it is given that the force being experienced by the negative charge is downward, which means the electron cloud is also made up of
Negative
negative
charges.
charges. I just corrected
Okay.
myself, right?
Okay.
And again, this is more of an illustration to help you broaden your thought process. Looking at a very long question, you can get lost in words.
Right.
Okay, and understand, oh, what's happening, what the hell is it? Okay, anyway. Now this is what he says. The All right. So first of all, we know that this is a negative charged cloud. If you place some charge on it, it experiences this much force. Let us say with this information, if can we find the electric field due to this the cloud of charges? What is electric field equal to? Force experienced per unit charge
Okay.
by an external
By
charge
Q,
Q.
right.
Make sense? Okay,
Yeah.
what is your external charge? This one, which is the negative
Minus
charge you
Q.
placed.
Right.
So let me calculate the electric field produced by the cloud. This is the electric field. 3 into 10 raised to power 6 is the force which the charge of 2 into 10 raised to power -9 is experiencing. Okay, I think
Right.
it's minus here. Okay, so this is 3 by 2 into 10 raised to power minus 6 plus 9. So E cloud, the electric field of the cloud is equal to 3 by 2 into 10 raised to power 3 Newton per coulomb. So we have come to know something
Right.
about the cloud, right?
It's
Then he says,
right.
then he says, please place a proton near this cloud. So I'm redrawing this figure and I'm saying, okay, same cloud. Okay, let me draw a cloud in fact. Okay, so that you understand it's a cloud. So the cloud is negatively charged and I know the strength near it, which comes out to be this much. The electric field of the cloud is this much. I was able to calculate it because he gave me hints pertaining to the force being experienced by this charge. So I was able to establish the
Okay.
electric field of this cloud to be 3 by 2 into 10 raised to power 3 Newton per coulomb.
Right.
Make sense? Alright. Now I'm
Yeah.
keeping a proton here, which is a positively charged. And we are at the Earth's surface also. Everything is happening near the Earth's surface. Tell me, this proton, will it try to
Right.
go up or down because of the electric field of the negative cloud?
Negative. It should go
Go
towards
towards
the cloud.
attractive, right? So let's say
Right. Attract
exactly.
upwards.
Exactly. So let's say the electric, the force which is experienced by the proton will be given by this formula again, q multiply by e. So what is the charge on a proton? 1.6 into 10 raised to power minus 19 multiply by electric field, which you have calculated,
Okay.
3
3
by
by
2
2.
into 10 raised to power 3 is equal to zero point 0.8 into 3 into 10 raised to power
So
minus
point.
16, 2.4 into 10 raised to power minus 16 newtons. So if you notice, the first thing, the force which the proton is experiencing upward due to the presence of the electric field of the cloud is upward. So the electrostatic force being experienced has been taken care of on the proton, right? Let's get back to class
Right.
11th now, because the question also talks about one
Okay.
thing, which is the concept of gravitational force. If you are on earth, you experience a gravitational force depending on how far you
Capital.
are, which is given by
Okay.
g m1
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 M2
m2
by.
by r
Okay. R
square.
square.
Or there is a simpler
Okay.
method, because you may not be remembering this g, you may not remember the mass of the earth,
Right. Right.
because you need the second mass also, right? Which in our case is the whole earth acting on the proton. Now that's very funny, right? It's too difficult, too tough, right? I mean, how do you memorize it? Somebody may
Of
not be able to
course.
memorize. So the force which is this force is actually the weight of the proton also, one and the same thing.
Okay.
In
Mg.
a simpler
Right.
manner, right?
GMG by R
If I know the weight of the proton is 1830 times that of a electron, so I'm calculating the force now. So this is my mass of the proton into 10, which is acceleration due to gravity. Okay, so this is 1838 into 9.1. Let's say 9 8s are 72, 9 3s are 27, 34, 9 8s are 72, 75, 9 1s are 9, 1642.9. Okay, let's
Right.
approximately, let's call it 16542. So this is the force, the gravitational force, which is nothing but the weight of the proton itself. This is mass of the proton. Mass of electron is 9.1 into 10 raised to power minus 31 kgs. Therefore, the mass of proton is 1838 times the mass of the electron, and therefore the force being experienced by the proton is mpg. G is acceleration due to gravity, normally taken as 9.8 meter per second square, but I've approximated as 10, which is what I've done here.
Right.
So sometimes you do get questions in NEET examination where you, after doing this, they may ask you to calculate find the ratio of force due to the Coulomb's law, which is the
Okay.
electrostatic force divided by the gravitational force, and see what how do they compare. You may get a number like 1000, 1 by 1000. Then you can say the electrostatic force is 20,000 times smaller than the gravity. That's a comparison. When you do ratio and proportion, you're trying to compare. But in this question, they've just given comma, comma. That's all. If you look into the choice number
Great.
A and D, look at the choice number A and D in the
Yeah.
question. There is a 2.4 mentioned, which is what we calculated as the electrostatic force, right?
Yeah, yeah, yeah.
Right. So at least we know. And choice
It's
number
one
C,
of
C
the
also, by the way, also has
yeah.
a is also here, right? And if you see my answer of 1.65, it is pretty close to the choice number. If you
A.
see A, yes, because I get both the answers in A. I get a 1.65 also, close to that, and I also get
And
a
okay.
2.4 into 10 raised to power minus 16.
Okay.
Tell me what did not make sense to
Okay.
you and you found it pretty stupid.
In
Anything that you
what?
found stupid,
Uh,
making no sense to you.
in the question?
Yeah, in my answer, which I explained you, something that was not clear to you.
Uh,
It was a very verbose question, but a
I
very
know
simple
everything
question.
was okay.
Yeah, it was the word like
Yeah, I was
like
saying
the cloud and a cloud. So that would scare you off, but don't get scared by words. It is a
the question.
yeah, the source of electric field instead of a cloud. Sometimes this is what they will do. They will say there is no cloud, but a electric plate
Yeah.
like this.
Right, right,
Now
right.
this plate is, for example, positively charged, and this is your proton, and it is very close to
Okay.
this,
Right.
right? So this plate actually is producing an electric field only, and we know the force is equal to E multiplied by Q. If I tell you the electric
Right.
field is 2 Newton per coulomb and the charge is a proton, you will say the force being experienced by the proton is 2 multiplied by 1.6 into 10 raised to power minus 19 newtons.
Okay.
So I have not used heavy duty words like a cloud. I've just said a metallic plate is like this and a proton is placed close to it. What is the repulsive force being experienced? So you say, okay, I'm only concerned with the electric field produced by the metallic plate. Next, don't touch your hair.
Uh,
Don't touch your hair. Don't touch your ears.
okay.
Do you know? Do you know
The
what is the meaning of the word fiddling? Fidgeting. Like your legs are moving, your hands are moving
oh yeah, yeah,
continuously,
yeah.
right? You
Right,
touch your
right, right.
skin, you touch your face, then you touch your hair. You know, you're in love with yourself. You have to be in love with physics at this moment. The self love will take a backseat in your cupboard. No
It's
loving
not
your
that
hair.
I haven't
My hair,
started it.
my hair are also very nice, by the way. Okay, just for your knowledge. But I don't touch them. I don't like them because I get
It's
them cut.
itching me.
Apply ketozone. Anyway, I'm just kidding. Just
Yeah.
just humorous. Next question. Okay.
The question this let me find the number.
Hmm.
This is I think it's 20.
Question number 20th. Again, a longish type of question. Okay.
Yeah, the
But
long one.
but
It's
this
graph.
question I will tell you what it is, but I will not get into details of this, but I will explain you the situation because you may not be aware of the class 11th part of it. Okay. Since you're
Okay.
preparing for class 11th and class 12th, we will have to deal with these types of questions separately. But let's even understand. We were also not dealing with gravitation in this chapter, but still we picked it up, right? So what we're going to
Right.
do, we are going to draw the diagram and tell you what's happening here, so that at least you have a broad perspective. Just in case you are hit by questions like these, you are able to at least know what's happening. So this is weight, and this is your again an electric field. Okay, and I will read the question now. So you see that the spacing between the lines of electric field is identical.
Right.
It shows it's a uniform electric field. If this
Okay.
spacing is identical, then you are talking about a uniform electric field. If the
Yeah,
spacing
okay.
looks like this,
It's a non-uniform electric
yes,
field.
closer the electric lines of forces, stronger the electric field. Farther they are, weaker it is. So if you place a charge here compared to a charge here, the charge here will experience higher force because it is placed in a region where the density of electric field lines is higher. If you keep a charge here, the force experience is low because there is a lot of gap. It's a weak electric field.
Okay.
One more neat type of question. All right, let's move it. So you have this situation. You have mg, you have e, you have theta, and what does it say? It says there is a small object and it has a charge q on it. So there is an object, and this object is also tied to a string. And then
Mm-hmm.
strangely,
Of length.
strangely, if you don't have this electric field and you do something like this in your house, okay, try this. You you have a nail, attach a string, attach a small bob or anything object, leave it, it'll come falling like
Moves.
this.
Right.
But it didn't happen in this case because the electric field starts from positive and goes towards negative, and therefore this particular charged body is running away from the positive. So it itself is what? Maybe a positive.
Okay.
I'm very certain because I know the direction in the diagram is from left to right. So therefore my electric field is like this. The left side is positive and the electric field always starts from positive to negative. If this is a positive charge and this is a negative charge, the electric lines of forces are like these. They start from positive but terminate at negative. Clear?
Okay.
And therefore I could guess that this charge is positive because it is running away from the positive side. This was the positive side. I hope this is making sense to you. So there was some positive side which was producing electric field lines like this in a uniform manner. Don't worry about wrong
Right.
spacing which I've shown, but it is equal in the book. Now this, tell me what is the force being experienced by this charge due to the electric
Mm,
field?
the one
The
acting
electrostatic
into.
force.
Okay.
Right, I'm now just drawing the body. One force it is experiencing is the electrostatic force towards the right hand direction, which we have
Yeah,
established.
because
It is
the
running away from the positive side of the electric
positive.
field and it has to be
Yeah.
positive. Okay,
Yeah. Yeah.
so much for your electrostatics. Now there is another thing. It has a weight. Earth is pulling it down. It is not a weightless object. It has a weight. Earth is pulling
Okay.
it down.
Okay.
Force number two acting on it simultaneously. The gravitational force. Third, the tension in the string.
This but okay, stationary support. Uh, the system is mm, weight. Okay,
Weight is there.
weight is there. Weight mg is attached to one end of the string of length L,
Yes. This is
and that's
length
it. And the
L.
support is stationary.
Yes. Since
Okay.
the electrostatic force came, this is what happened, right? The object which was lying, would have been lying ideally like this only. If you leave it, it would have fallen, collided, and then stationary. You switched on your
Okay.
electric field, it ran away like this. And now there
Right.
is a tension in the string.
To hold it there. Yeah.
Yes. Now what is happening? There is an electrostatic force which is
Mm,
like this. There is
acting.
a
Right.
weight and there is a
Acting
tension.
downwards.
Yes.
Right.
And there is a tension
Mm,
at an angle theta.
okay.
This is where the object is at equilibrium, which means all the forces
Okay.
are
All the forces are acting same. Yeah. Like I mean,
balancing,
canceling out.
cancelling
Yeah.
out in both the directions, x axis and y axis.
Okay, okay, okay.
Okay, just remember one thing: if you have a body like this and you have a thread connected to it, this is your hand, for example, right? And you try to pull the
Yeah.
body up. You try to pull the body up. Whatever is the weight of the body generally will is the tension which is getting produced in the string. Okay,
Yeah, yeah.
so there
We
there is
covered
a
this last time.
yes, exactly. Absolutely. Now let's say the tension in the string is T, and we know this body is in equilibrium. So now we have to discuss what? Equilibrium of this body. Tell me, the T tension has two components if I were to draw. Okay, so I will just draw, and let me just rub this off because this is not a straight line. I want to draw a straight line. Okay, so this is your straight line, which is the wall. Okay, and this is my tension. Tension always works away from the bodies, away from the bodies. It never is towards the body. If you connect
Understood.
two identical objects with a thread and you pull it from this side, when you pull using your hand, the tension is acting here on this side, and on this side it is acting here because of this string. So whatever point is touching the body, the string is touching the body, the tension is moving away, not towards the body. If you have a body, you are pulling it, the string is touching the body here, the tension will be away from the body. Never ever
Okay,
you can have a situation like this, that you're pulling the body and the tension is towards the body. Not possible. So
okay, got it.
therefore this is your tension, this is your angle theta. I will draw the resolution. I will say, okay, this tension can be divided into x component and y component like this. This is theta, and therefore anything which is opposite theta is t sine theta in a right angle triangle. Anything which is opposite of theta and the hypotenuse is t will be t sine theta. Anything with the theta will be t cos theta. So this is my t cos theta. If I go back to my diagram, this therefore is how much? Is t cos
Mm,
theta, identical to this one, base, the base of the triangle. And then
Advanced.
yes, and then the perpendicular, right opposite to the angle,
Fine.
towards the left. Now tell me, the body is stationary as per the question. Can you see that why the body is stationary in the y
Because
axis?
this is,
Because
yeah, yeah.
mg is equal to
Tau acting.
cos theta.
T cos theta. Okay.
I was
Got it.
able to break down t in two parts, x and y.
Right.
Okay?
But they asked us the magnitude acting on it.
Exactly. So first we will do the equilibrium conditions,
Okay.
and then we will definitely find that. Tell me, in x axis what's happening? In the x axis what's
Mm,
happening? You have a t
it's T
sine
sine
theta
theta.
which is
Yeah.
towards the left,
Right.
and on the right hand side which force is there? This one, which we calculated,
Q
electrostatic
F
force.
electrostatic force.
So
Right.
so the tension has balanced the weight and the electrostatic force, and therefore the body is
Yeah.
stationary now because of these reasons.
Okay. Okay.
Tell me if you have a doubt in your mind.
Mm,
Equilibrium, it's a question
no.
of, whenever you hear the word stationary, you're talking about equilibrium. Make sense?
Got it.
All right.
Yeah. Yeah.
What is the question? You have to find the, and you also know the length, by the way. Okay? The length of the
Um.
string also is
Yeah. L.
L. It is known to
Right.
you. You have to find the magnitude of Q. I have told you everything, but look at the options now. First option,
Yeah.
okay, it says the what is the sign of Q? Tell me, out of the four choices, what do you think is the sign of Q now? Is it positive or negative? We started with
Uh.
that. We started that it is running away from a type of electric
mm,
field, which is,
It should be negative.
but then it will move towards left. because the electric field is from positive to negative.
It so
It ran away
positive to negative. If it's running away
from
from if it's
positive,
running away from positive, so it should be negative.
so it will get attracted. Unlike
Uh,
charges
uh,
attract.
oh right, it should be positive. Right, right.
Repel. Running away means
Yeah, yeah.
repel.
Going from positive. Yeah.
Right?
It should be
Positive is pushing
positive.
positive. Don't come near to me. A
Right. I got
positive.
it. I got it.
Understood? Okay. So
Yeah.
look at the choices now. The choice number A, B, and D may be
I think
right.
you should. Right. Yeah.
But what about the magnitude? That is decisive, right? Let's say what is the magnitude. If I
Okay.
were to divide these two equations of equilibrium, what is that I will get?
Cosine
I am
sine
dividing
t-
2
tan
divided by 1.
2
Okay, so 2 t sine theta divided
by
by
cos
2 cos theta is equal to
tan.
q e divided by mg, and tan
Okay.
theta is equal to q e upon
Okay.
mg. So
Tan mg.
q is equal to mg tan theta divided by
Okay. Wait. Which of the options? Mg tan theta by E is uh theta.
q is equal to mg tan theta by e, which is the option number B. The
No,
tan
no,
theta.
B is mg by E.
So which is
Okay.
this, right?
Into tan.
I mean,
Okay.
it's
Okay.
a way to write, right? You can write this
Yeah. Yeah.
as
Yeah.
in
That's what I was
a
confused.
very bracketish
I
manner,
got it.
as if you're learning board mass, right? We're not learning board
Okay.
mass here. We're learning physics. So this
Got
is
it. I
it.
got it. Got it.
So
Okay.
look at the number of concepts which are getting applied. The knowledge of electric field, deciding the sign of the charge, and then the
Right.
11th standard knowledge of equilibrium. Being able to say it is stationary, I will write two equations in
Mm.
x-axis and y-axis. Knowledge of resolution of force. How do I resolve this T in two parts?
And
This,
theta. Right.
yeah, this they told in the question it stops at an angle theta with the wall. So tension is away from, and I divided the tension in two parts. The resolution.
God.
Done.
Yeah.
All right. Let's go to the next
The
one.
next is the next one only.
Okay.
The di
Deuteron.
Deuteron.
Deuteron. Okay. So deuteron.
Newton.
It's called deuteron. You will learn about these when you enter later chapters of atomic physics. Okay.
Okay.
All right, and you will learn about heavy water and stuff like that. Anyway, so there is a deuteron and an alpha particle. Okay. An alpha particle is nothing but a helium charged
Positive.
positive, right? What is a deuteron, if you remember? Hydrogen.
I haven't done it yet.
You haven't done. Assume you okay. So the mass number is 2, atomic number is 1, and this is 4 and 2. Okay.
Okay.
Now
Okay.
what you have done is they are separated by a distance 1 Armstrong. I don't know how to draw 1 Armstrong, but I know the R between them is 1 into 10
One
raised to power
ATM.
meters.
Okay.
So
Yeah,
the
yeah, yeah.
spacing between them is known to me.
Okay.
Okay, let's talk about the what is to be found out. You have to calculate the magnitude of electric field intensity on alpha particle due to the deuteron. What is the intensity of electric field produced by deuteron on the
Alpha particle.
particle? Deuteron by the way is not even charged like alpha particle.
Okay.
It has no charge on it. If you
Okay.
don't have a freely available charge like a positive sign like this, how can you produce an electric field? You are a deuteron,
Means
you are neutral.
right.
I could have calculated the electric field due to helium, which is positively charged, and said the electric field due to helium is kq by r square. I know
Where is
the
it zero?
medium between them is air, so 4 pi epsilon naught into the charge, which is positive charge 1.6, into 10 raised to power minus 19. What is the distance between them? 1 into 10 raised to power
1
minus
into
10
10 to power
whole
10
square.
square.
So this is my electric field due to alpha particle. But electric field due to deuteron makes no sense. It has no charge on it. A deuteron.
Okay.
So
It should
answer
be
is,
zero.
it is
Option B.
incapable of
Okay.
producing any charge, any electric
Okay.
field.
Right. Got it. My next one was question 26.
26.
The
Okay. No problem.
sphere cylinder. They asked us which is the best suited to retain charges for a longer time. I'm not sure of this. I think I wrote,
Okay.
uh,
What was the
I wrote
question?
sphere.
You haven't done the theory of this.
Yeah, I have
Okay.
not.
No, but I will give you a perspective again. Don't worry about it. Even if
Okay.
you have not.
Yeah.
You knew something which was pretty nice. Okay, which is the
I knew. I
conduct
just wrote sphere.
conducting. Yes, I know. You have not. If you just read it carefully, you will get the answer also. If you have a
Okay.
plus charge like this, the question is the electric permittivity are same as this. Okay, so you're referring to 26. Four metal conductors have different shapes. Okay, so
Yeah.
okay, and then you have a cylinder.
Right.
Okay, you can go to NCRT and find out the expression of the electric field due to a cylinder near the cylinder. Okay, it is also
Okay.
charged, so that's a Gaussian surface. And when you do the
Yeah. Yeah. Yeah.
derivation, you have to surround it with the external cylinder
Magnetic. Okay. Okay.
when
Oh
you
yeah.
do
Yeah.
the
Yeah. You
Gaussian
did.
derivation. And then there is another one which is the pier. How do you draw a pier? Okay.
Like a
Mm,
non-uniform field, basically.
I hope I've drawn it correctly. I'm just trying it.
Yeah.
All
It's
right.
like a ball for
Absolutely.
bowling.
Yes. I will come to this. Don't worry. And then you have one more shape which is the shape
Uh,
of a lightning conductor. You know, lightning conductors are available on top of high-rise buildings. So
rectangle.
if you have a house where you lived in, right now you're in Nigeria, but in your Sonipat house, if you go to the terrace, you will find pointed, very sharply pointed electrical lightning conductors. Whenever the light
Okay.
strikes from the cloud and comes
Okay.
down, breaking the air. Air is an insulator. It generally does not allow any charge to pass through it. But on a rainy day, there is too much charge here. Very strong
Right.
potential difference
Lightning
gets created
goes on
between,
that.
yes, lot of
Okay.
potential difference between the cloud
Is
and the
it
earth.
is it like a copper plate?
No. Yes,
Okay.
that is earthing. When you say the
Yeah, yeah,
copper
that's what
plate,
I was
that is
talking about. The
earthing.
copper
Yeah.
connected to
So
the
that's
earth.
below the building. What I'm referring to is a lightning conductor. If light
Okay.
strikes your building, you want to provide a path to the charge to flow down and reach the earthing. Otherwise, there is a danger it may enter the houses. But you already have a lightning conductor which is going through the building, and the
Mm.
charges love to go through the path of least resistance. They find a lovely, sharp lightning conductor through which they pass without causing any damage. If people are standing on the terrace that day, when the light strikes, the charge that comes from the cloud will not hit the people
Right.
but would love to
Oh,
go to the lightning conductor.
okay. Something more. Okay,
Yes.
makes sense.
So people will not get injured. Okay. Now let's talk about a pier. Do you see a pier also has a shape which is like has some pointed stuff like this, right?
Yeah.
I mean, it's not as pointed as a lightning conductor. Lightning
Okay.
conductor is too pointed.
Makes sense.
Okay, but it is not as good as that one, right? So, but the question is, you want the charges to be retained. You want the charge to be retained on it, right? This particular
Right.
lightning conductor will not retain the charge. It will get the charge and it will send it through and finish.
Right.
It doesn't. You don't need to retain anything on it. You want it to be used for conducting. That is flow of charge.
Okay.
Even this particular body, okay, also if you notice has some part which is not exactly circular but somewhat cylindrical, if I may say. I'm just guessing. I mean,
Okay.
it's very hard to define the shape of a sphere, but it has some component which is pointed and some component which is roundish.
Right.
Let's go to a cylinder now. This one. Okay? And then
For
let's
sure.
compare this to a spherical three-dimensional structure. Sphere. Even this is a three-dimensional cylinder. It is.
Yeah.
Right? Now, if you notice, the electric field due to these is perpendicular. Supposingly these are positive charges, appears like this, away from the cylinder. And also for a sphere, the electric field is away from the charges. There is no
Right.
charge which can reside inside a sphere. So there is no charge which can reside inside a sphere, and the electric field is
Right.
also zero.
Zero.
If you
Okay.
notice, this is the most pointed. This is
Yeah.
lesser pointed. It has roundish,
But
right?
yeah. Okay.
So what will happen? Anytime you try to throw a charge on this, that charge will tend to go towards the rounded part.
Okay.
And if you have a cylinder is also like this, right? The upper part.
Yeah. Round.
Even it is like a broad, even it is like a broad conductor. Like this is a very pointed rod. So the cylinder is not a rod. It's obviously pretty large, right? But
Yeah.
it still is something like a straight. But if you look at a sphere, you keep on providing charge to a sphere. The charge keeps
Yeah.
on, spreading uniformly on the,
Yeah.
right?
Like quantization.
Yes,
Right.
yes. No, no. Quantization is being multiple of E,
Okay. Right. Plus and okay. Both. Right. Right.
right?
Right.
What I am saying is, if you give a charge to a sphere,
Points.
it spreads itself uniformly. What
Yeah.
happens if it spreads uniformly? The electric field on the sphere, the electric field on the sphere,
Yeah.
right? If it becomes greater than the value of electric field which the air can tolerate around it, air has a tolerance for electric field beyond a certain value. If your electric field goes up, air no longer remains a conductor, an insulator.
Okay.
I'm sorry. Air is generally so if you have a spherical conductor which has a lot of charge on it, it is also having electric field. The air molecules around it have a limited caliber of tolerating the electric
Reach.
field.
Okay.
Every insulator like bakelite, mica, and all of these have a limited capability to handle the electric field. After that, they break down. Like in the case of cloud burst, the air breaks down electrically and allows for charges to flow.
Okay.
In the case of sphere, because the charge spreads uniformly, the electric field does not become very high at any point. In this case, the electric field is bound to become very high because here the electric field which you will have as compared to the roundish, in the roundish place the charges spread and distribute, but here the distribution is limited. But in the case of a sphere, it's a uniform distribution all over, and therefore at no place you have excessive charge.
Okay.
But in the sphere, there is no way to have for example, if at a point on a sphere, the sphere stops behaving the way it does, you give it 60 coulombs, out of
Right.
which 59 coulombs come here, and the balance 1 coulomb spreads all over.
Okay.
This charge will produce an astronomical electric field. Got it? That
Yeah.
electric field will break the air around it.
Okay.
Because the air is insulator, it will break that air. We call it electrical breakdown of air. You will see sparks coming out because now this charge of 59 coulomb will start flowing in the air because it has broken the tolerance of the air.
Okay.
There is a value you can read. I will send you the value. What electric field air can tolerate? What is the maximum? It will cross that.
Okay. Okay.
So if you
Okay.
want to keep a charge for a longer period of time, always keep it
Yeah.
on a body which can hold the charge in a uniform manner and does not allow the charge to get concentrated at a single place.
So it's peer only.
Exactly.
Okay. 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 Got
What
it.
a long story. But I had to explain you. I could have answered in 1 second, but I had to explain you. Please do not.
Yeah.
When you look at the figures, you have to say, okay, this particular bugger has a full caliber to hold a charge somewhere. It'll right.
Right.
And look at electrical conductor. The pointed electrical conductor. It is such a nice conductor. It does not hold any charge. It sends the charge through it. The whole charge part, and you want to retain the charge. Right? Look at this sphere. Here you may get
Peer
more
makes more
charge,
sense.
and here you may get
Than
less
the
charge.
circle.
So the upper part will have a very high electric field. The lower part will have low electric field. Again, non-uniform, right? There is a chance that the upper part may break the air around it.
Right.
But this one, whatever charge you may give, spreads uniformly, and therefore is not going to create a
Most
spike of
uniform.
electric field to be able to break the air down.
Okay.
Make sense? I got to go for my next class now.
Okay.
Okay, I'm going to send you some more questions, or if you have these questions, continue to do them and identify. I will send you an assignment to do for MCQs
Yes.
for a while, so that you get
Okay.
acquainted with lot of concepts.
Okay. Okay. Okay.
Make sense?
Yeah. Yeah. Yeah.
Right? I have recorded this session. I will upload it on YouTube also. You can show it to your dear friends in Nigeria.
Will I be there in it?
Yes, there is a good possibility you may be there.
My face?
Yes, you'll,
No.
nobody knows. Nobody knows in India where you are and who you are. So don't worry. Nothing to be
I know.
worried
I
about.
know. Just,
Right?
just remove my face.
No, you are going to become a brand ambassador, the international ambassador for my institute.
No. You can blur me
We
out.
will pay you royalty next year, not this year when you get selected.
Right. Right.
Chalo, see you
Yeah.
then.
We can. No. You can
Oh,
blur me out.
okay, I will blur you out. We will say this is anonymous. Okay, no, don't worry,
Yeah.
don't worry, don't worry. Nobody's going
I
to
know. I
bother
know.
you. Your number is not there. Nothing is there, so you don't need to worry about
I
it.
think only your keyboard, like just पे
अच्छा ठीक है.
corner बने हैं
अच्छा
वो आ
ठीक
रहा है
है
ना.
ठीक है, मैं वो लिख दूंगा किसी कारणवश ये जो है मोहतरमा इनको अपनी शक्ल नहीं दिखानी थी. ठीक है, we will do that. All right.
Privacy.
Oh yeah, I will write
Yes.
privacy. European laws in Nigeria. ठीक है. Good.
Yes.
Keep it up. ठीक है. Thank you so much. See you soon
Okay.
then.
Thank you.
Keep
Bye.
keep trying questions and
Yeah.
keep attempting. Stay in touch. I'm going to send you some more.
Okay. Okay.
All right. See you
All
then.
right.
Bye.
Thank you. Bye.
Bye.